Hello everyone and good morning. Today I will introduce about the telemetry project and how to use the telemetry in large-scale systems. Okay, we are United Stack and distribute unified open cloud platform in China. And I am developing leaders in United States. Okay, first of all, let us see our test environment. And in our OpenStack test environment, the control node, three control node with the hardware show on tables, and the computer node also, and with 6 storage disks. Also for, we run some testing virtual machines on this platform, and the virtual machine is about 2,000, and each machine have 2 core, and we show here. And what problem if we use telemetry here? And we find that the resources heavily run out. And first of all, the utilizations in controller node. CPU is, the utilization is greater than 70%, okay? Then the memory is over 18%. And also, we can find that the message queue and in the queues in web queue, the message is keep increasing. As well, the utilizations in the compute node, we find the disk utilization is also very high to 90%, and it's very busy. And we use Ceph for the backend storage here. So today, we will introduce what the telemetry is here, and the challenge in telemetry and best practice in production environment. Also, we showed some improvement in future, maybe. Okay, so what telemetry is? Telemetry is the monitoring service in OpenStack. And it's now have 4 projects and Ceilometer. Ceilometer is gather and dispatch data and not do anything others now. And Gnocchi is persistent sample data from Ceilometer. And Panko is persistent and query event data from Ceilometer. And 8 is the arming based on the sample and event data. Okay. So what's the problems in default configurations in telemetries? As I said before, that you can find the base, the hardware resource is ran out, and it's very heavily used. And so on the user layer, you will find these are phenomena, and you can find the Gnocchi API, call one Gnocchi API is more than 20 seconds about. It's so long. And also, the Ceilometer notification engine is slow, because if you use Ceilometer to publish your sample data to the Gnocchi API, because Gnocchi API is slow, so the notification engine becomes slowly. And also, if the notification engine becomes slowly, the RabbitMQ will be blocked, because the messages in the queue will keep increasing, and finally the memory will run out. Okay, so this is some of test result in details, and what the CPU and memory is used. And the second table shows you each service cost the CPU code. And here, the most heavily used service is Gnocchi API on CPU, and memory is heavily used in notification engine. So I will introduce why this will be and in the later slides. Also, you'll find that we use Ceph as a telemetry backend now, so the Ceph utils is also heavily used, and it's about, under 2,000 virtual machines, it's about 3,000 IOPS per second for read IOPS and for write IOPS. So, let's see how this will be. And first of all, I will briefly distribute these Gnocchi architectures here. And this is from the OpenStack document era. You can find it. Gnocchi is the storage backend is for store sample data, and it provides APIs for user. And on the back end, it have 3 storages. One is major storage. One is aggregated storage. Major storage is the incoming measures from the API and temporary stored measures. And aggregate storage will aggregate data from major storage, and it's according to the metric deep processing. And the index is storage is to store the metadata and the resource ID and so on. So first of all, let's see the backend storage issues here. We use Ceph here. So why Ceph is heavily used in this case, and even in SSD backend, 3,000 IOPS is very less for SSD. But at the backend, you find, I show you that the disk utils utilization is greater than 90%, right? So why? You can find that if you know in Ceph, Ceph use RockDBs or level DBs to store their key value data. So here, in the major storage, actually, it is a key value pairs and to store, temporarily stored in the storage. If we use Ceph here, what problems is we will suffer the wide amplifications for level DB and RockDB issues. You will find in these figures that if the user data is just 55, and the wide amplification of the RockDBs will bring the real data wide and read up to approximately 2,000 gigabytes. So this is the reason why the backend, the disk will be saturated. And so maybe you will ask why about files or Swift? Because files, if we use files, we need maybe NFS and use pacemaker to do the HA and something like others. And you should build on your own high availability shared file system. So if you use Swift, it's the HTTP protocol, and it's also not good. So Ceph may be the maybe currently best way, but it's also have a problem, right? So how to deal with that? In the Pike release, the newest release version of OpenStack, right? You can separate the configurations of the major storage and aggregate storage. So you can use, you can set the incoming here and use the Redis backend as the major storage. And for the backend storage, you can use Ceph, so it will elevate the pressures much. And here is the second is the Ceilometer issues. Assume you have 3 Ceilometer notification engines, right? You consume the reference queue, the samples in the queues, that A1 A is the metric, and B also metric, and here. So it's, the notification engine will consume those things. And so what will be? You will find that maybe the first notification engine have A1, C2, A3, and the third notification agents got A2. What problems here? The problems is the in Ceilometers, we maybe not use raw samples, and maybe the raw sample will do transform, and according to based on the transformer, the policies. For example, here the disk read per second, we should use delta, the delta values and over period, right? So the delta, how we get the delta value is the current samples minus the previous samples. Like here, in the first Ceilometer engines, is the current may be A3 and the previous is A1. So A1 should be cached and until A3 is arrived. Now it becomes A3 minus A1. But however, the real data is maybe A2, but A2 go to another notification engine, right? So it just got A3 here. So this may be inaccurate calculations. Also, if you can find that A1 is cached here, A2 is cached in the third notification engine also. So for the same metric or the measures, it caches all the data according to all notification engines. So this is the problem here. So this is the reason why you find that the Ceilometer notification engine costs so much memories. So we can use the sharding policies here and do the dispatch, and then RabbitMQ also have some problem because time is not enough. So we just showed it here. Here is the configurations to solve these problems and use the workload partitioning. So you can use workload partitioning and the sharding policies and do here. And also, remember, enable the RabbitMQ prefetch count, prefetch policies. Otherwise, you will got an error here. And last Gnocchi API issue. Maybe I think maybe this is another issue, but time is up. Okay. So the future works maybe the HTTP issues we will test. We can use Ceilometer UDP dispatchers and the Gnocchi state. So this will not use HTTP protocols. And also Ceph.io issues are other time series storage backend we can use because Gnocchi came very easily to develop drivers. Okay. So today we will introduce this, not in details, and about Gnocchi backend issues, Ceilometer memory issues, and CPU issues here. Next time we may introduce more about details deep inside and how to make use of Gnocchi state D and real data in test data in maybe 500. More than 500 computer node cluster. And so if you are interested, you can voting us in next summit. Okay, thank you, and see you next time.